couple where I'm solving again because I made your problems yesterday very easy. You didn't know it, but they were really easy for completing the square. So we're going to be solving some where it says right here, a is not equal to 1, and that makes it a little more difficult. And then we also want to talk about how we can use completing the square to rewrite things in Vertex form. So this might actually be my first example yesterday, but I changed it by putting a 2 in front of the x squared. I think yesterday it was x squared minus 8 plus 5. I mean, you could stop and check to see if this one factors, but I don't think it does. Okay, so we're going to solve by completing the square anyway. And the first part of this is the same as yesterday. So what would be the first thing we would want to do to complete the square? Get the 5 on the other side. Completing the square is for some x squared and x term. It has nothing to do with the number that's already there. That's not a perfect square trinomial. I can't factor it so that the two factors are exactly alike. So this number needs to just like go to the other side and sit there for a while. It has nothing to do with completing the square. So I'm going to say 2x squared minus 8x equals negative 5. Now here's where you have to be really careful. I am not allowed to just take half of the middle term, negative 8, and square it and get 16 and say that 16 is the number that completes the square. Okay. If I said that 16 was the number that completes the square, if I write that over here off to the side, 2x squared minus 8x plus 16, I'm saying that when factored, the two factors are exactly alike. Well, that could factor out a 2. Do you have factors of 8 that add to make negative 4? No. So it doesn't even factor, let alone give you two factors that are exactly the same, right? So 2x squared minus 8x plus 16 is not a perfect square trinomial. So if you flip back in your notebook and look at all the examples we did yesterday, or you look at all your homework problems from yesterday, never did I ever have anything in front of x squared. So we're going to have to add a new rule right here. Factor a out of the x squared and x term if a is not equal to 1. So any other number, if there was a 3x squared, a 5x squared, a 1/2 x squared, oh, there it is.
It's hiding.
To something.
It was hiding around the corner.
It was hiding. Okay, if there was a negative x squared, I would have to factor out whatever that value is. So what are we going to have to factor out of both terms? 2. So the 2 does not disappear. This is really important. The 2 does not disappear. The 2 just gets factored out. When you factor something out, it's like you're dividing. So 2x squared divided by 2 is x squared, of course. And negative 8x divided by 2 is negative 4x. So you got to factor it out of both terms that are there. You can't just factor it out of the front. You factor it out of the whole thing. And notice how, the space where I left to complete the square, I left space in this parenthesis. Because now I'm going to treat this x squared minus 4. This is going to be where I create my perfect square trinomial. So the number that completes the square needs to be in that set of parentheses. What number completes the square for x squared minus 4x? 4. Half of negative 4 is negative 2. Square it. we're going to get a plus 4. Okay, so then we complete the square. Okay, now here's the other part where you have to be really careful for today. When you put in a plus 4, normally we used to just add 4 to the other side. Okay. But we had factored out an a value, which in this case was 2. So this is not really x squared, it's 2x squared. And this is not really negative 4x, it's negative 8x. So this number that I put in there is not really adding 4, I really added 8. So I always draw it like this, like I'm distributing the a. 2 times positive 4 is plus 8. So if I just added 8 over here, then I need to add 8 on the right. And that's really hard for people to remember. Okay? But that only happens when you factor something out, that you have to distribute it before you add to the other side. Okay, so now I can pull down my 2. I can write my perfect square trinomial now as a square of a binomial. So it's going to look like x minus 2, half of 4, or the square root of 4, and then that equals, what is that, 3? Everybody okay so far? Anybody got any questions about where my numbers came from? Okay, how would you solve for x now? Divide by that 2. Don't try to distribute the 2 because you can't distribute into something that has an exponent. So we're going to divide by 2. That's x minus 2 quantity squared equals, and remember, I'm not scared of a fraction. I'll just leave it as 3/2. Then I'm going to square root both sides. This leaves me with x minus 2 equals plus or minus, and we just kind of reviewed this with Carly's question. We're going to do the square root of 3 over the square root of 2, but because the square root of 2 doesn't come out to a nice number, I have to rationalize my denominator. So I got to multiply it by a square root of 2. So this is going to be plus or minus the square root of 6 all over 2. And then last step, add 2 to both sides. X equals 2 plus or minus square root 6 over 2. Now, this is like 2 over 1. So I can't just like combine them together on the top like we did on the one Carly asked from the homework. If I wanted to put them all over 2, then this would have to change to 4. So that 4 over 2 is equal to 2 if you simplified it. But I would probably just leave it alone as 2 separate pieces. So you have 2 real solutions. If you actually calculated what that is, those would be your x-intercepts on your graph. They'd be in between 2 points. They wouldn't be nice points. And of course, we wouldn't have been able to find that through factoring, right? Okay, so you gotta be really careful. Never complete the square if a is not equal to 1. You have to factor out first. Let's do a rewriting problem. Okay, so this is the problem. This is the same directions that we basically have for 57 to 61, which I didn't tell you how to do yesterday. So some people might have looked at the example in the book and figured it out, and some of us might have been like, don't know how to do these, not going to do them. Okay. And in this case, that would be okay, because I intended to teach you. So, think about what's different in this equation than the equations we worked on yesterday. The equations we worked on yesterday, we actually said they were equal to 0, and now we're saying it's equal to f of x. F of x is a fancy way to write y. Okay, so this is y equals x squared minus 8x plus 5. If you think back to chapter 1 when we had different forms for a quadratic, would you agree that this is like y equals ax squared plus bx plus c? Standard form. And we want to take y equals ax squared plus bx plus c, and we want to put it in vertex form. Vertex form is the one that has which letters? The h and the k that are the vertex. So we want to transform it to look like y equals a times x minus h squared plus k. That's how we'll know we have an answer, when it looks like that. Well, what you should be kind of thinking about after yesterday is, I've got to go from something where I have 3 separate terms, and then I have to make it look like 8x minus h squared. That's like the square of a binomial. Did we write squares of binomials yesterday? Yeah, after we created perfect square trinomials. So we're going to use our skill of completing the square to rewrite this equation. So, normally, you would want to complete the square for x squared and x. 5 has no business over there, right? Let's move 5 to the other side. Y minus 5 equals x squared minus 8x. So the first step is the same. Move the constant to the other side. Can you complete the square for x squared minus 8x?
Mm-hmm.
Yeah, because the leading coefficient is 1. What number completes the square? 16. Half of negative 8 is negative 4. Squared is 16. And since I put that 16 on the right, I also have to put 16 on the left. I didn't factor anything out, so there's nothing to redistribute to it. So that's going to be a plus 16. This is y plus 11 equals, and then think about, why did I complete the square? I made a perfect square trinomial. What are the factors of 16 that add to make negative 8? Negative 4 and negative 4. So when factored, this looks like x minus 4 quantity squared. Is this starting to look more like that blue form down at the bottom? Yeah, what's the last thing I have to do? Move 11 to the other side, and I'm done. I got my k. So y equals x minus 4 quantity squared minus 11. What's my vertex? 4, negative 11. Yes, either one. You can do half of the middle term, or you can do the square root of the last term. There's a pattern for both.
Can you just like do that negative b over 2a?
You could, but this is a skill you're going to need in the future. So like you redo this in pre-calculus, and then this whole completing the square thing, you redo again, like you redo it with the quadratics again. And then you redo it in semester 2 to do conic sections, but then you have to complete the square multiple times. And so you wouldn't want to not know how to complete the square. So yes, could you do opposite of b over 2a, plug it in to find y, and then that be your h and k? Yes, you've made a connection there. But we're trying to build our skill of completing the square, which is really important down the road. So for these problems, when you're asked to rewrite in standard form, I would try to complete the square. Yeah, it's 1. Sure. What's your a gonna be in this one? 4. Okay, so I'll just real quickly do this one. I'm going to change this y plus 12 equals 4x squared minus 8x. Are you okay with that? I changed f of x to y, and I added 12. Move the constant to the other side. Now, what did we just talk about? Since there's a 4 in front of x squared, I have to
Factor.
out that 4. Cannot complete the square. Do not complete the square with -8. That thing that you would put there, you would do half of -8 is -4 squared is 16. That would not factor. That's not a perfect square trinomial. So I got to factor out the 4. That leaves me with x squared
Minus 2x.
minus 2x, and then leave space to complete my square. Okay, what number completes the square for x squared minus 2x? 1. So I can put in a plus 1. Should I put a plus 1 on the other side?
No.
No, because I added more than plus 1. Right? This is 4x squared, this is -8x, and this is
Plus 4.
plus 4. So there's that whole thing. When you factor it out, you have to redistribute before you add to the other side. So I should really add 4 on that side. That leaves me with y plus 16 equals 4 times x minus 1. Follow the sign of the middle term. Half of the middle term is 1, or the square root of 1 is 1, and then subtract 16. The vertex would be at 1, -16. Again, Jessica's method would work if we did opposite b over 2a, plugged it in to get the k, and then, like Alex's question about the a doesn't change. The a is going to be 4. It's still a vertical stretch of 4 for both graphs. So you would be able to do it that way, but you want to concentrate on completing the square, because it is a skill that you'll need later on. And I'll tell you what, my pre-calculus students this year, they're no good at this. It was hard. They were not happy. But they've learned it before, so I don't know what the deal is. But you should be able to do that, for sure. You want to be a happy pre-calculus student next year? Figure this out. Put in the time, put in the effort, it'll pay off. You'll be like, oh yeah, we did this last year. Okay. So your homework assignment is on your gold sheet, but on your gold sheet it just says like 41 to 49 odd, and then it has 63. But I put 57 to 63 odds because 57 to 61, if you didn't do those because you didn't know how, you want to practice those now. Okay, so if you need to make a change. Now if you're like, yeah, that's what I looked up in the book and that's what I did on my homework, then you don't have to redo your 57 to 61s, okay? But if you didn't get those done last night, then you want to do them tonight.